In the last lecture we were discussing about the clustering criterion actually, and in that way we are going to compare various partitions that are induced by clustering. So we had come up to this point that, let me just recollect, clustering criteria is what we were looking at. So this, what we are trying to do is to compare or comparing various partitions induced by clustering, and in order to derive the criterion we had said that suppose we have the data in the following form, that we have some dimensional data, say p dimensional data, we have x1, x2, xn, these n observations. So these are basically the n observations on the multidimensional data, and we had introduced this sample variance covariance matrix as sigma hat with a divisor say n, that is the maximum likelihood estimator, as 1 upon n I equal to 1 to n x I minus m, which is the grand mean, x I minus m transpose. We had defined m to be the grand mean in the last lecture. So with this sigma hat we had also defined a random variable, this I will say that rather than definition, define this zji, that was defined to be a binary variable taking values 1 and 0, 1 if xi, the ith observation, belongs to cluster j and is equal to 0 if it is otherwise. So with this zji indicator variable defined, we had the within cluster sum of squares and cross product scatter matrix given by the following. We had S w in the last lecture's notation, then a summation j equal to 1 to up to g, where g is the number of clusters, and I equal to 1 to up to n zji, that multiplied by xi minus mj. Mj is the cluster mean corresponding to the jth cluster, xi minus this mj vector, its transpose. So this we interpret as a pooled within cluster, scatter matrix over the G clusters. So suppose we have in a clustering algorithm giving us G clusters, then SW, the sum of squares and cross product scatter matrix, is going to be defined by this particular quantity, and we also defined this between cluster sum of squares and cross product scatter matrix, which is nothing but SB matrix, which is given by this sigma hat matrix minus what is the within cluster sum of squares and cross product matrix. And it is elementary to see that this actually reduces to j equal to 1 to up to q n j divided by n, and then we have this as mj minus m, the grand mean, that multiplied by mj minus m, its transpose. So this basically indicates the scatter of the cluster means about the grand mean, which is m, wherein here this nj term is nothing but summation of z j I terms for I equal to 1 to up to n, because z I j is equal to 1 if xi belongs to the jth cluster, and hence this particular sum of the indicators for I equal to 1 to n all the data is going to give us the number. So, this is the number of items in cluster J. So, that is the interpretation what we have. Now, having defined this within cluster sum of squares cross product matrix as SW, and the between cluster sum of squares and cross product scatter matrix to be SB, what we have actually the popular criterion for comparing various partitions are based on univariate functions of these quantities. So, the popular clustering criteria are based on univariate functions of this SB matrix or SW matrix or this sigma hat matrix or a combination of these matrices. Now, one such measure or one such criterion is what is given by the following quantity. It looks at minimization of the trace of one of these matrices, which is SW, minimization of trace of SW. So, what is trace of SW? Recall that what is SW from the previous slide here. So, SW is this particular quantity. So, we are looking at trace of this quantity. So, that is 1 upon n summation j equal to 1 to up to g, summation I equal to 1 to up to n, then we have zji, that into xi minus mj into xi minus mj transpose. So, we are looking at trace of this. Now, trace can be taken inside because trace of AB equal to trace of A plus trace of B. So, one can write this in the following way, that it is 1 upon n j equal to 1 to up to g, then we take trace inside the second sum here. So, it is zji and then trace of this quantity, which is xi minus mj into xi minus mj transpose, right. Now, trace of AB equal to trace of BA. So, we can write that as summation j equal to 1 to up to g summation over I equal to 1 to up to n, then zji into this quantity is nothing but xi minus mj square. So, this term is this only. So, what we have or what we can write is 1 upon n summation j equal to 1 to up to q, and then this entire term here, which is a function of j, which is depending on j. So, for the particular j we write that as Sj, where we for completion write that this Sj is nothing but this particular quantity, which is Zji xi minus mj square, this I equal to 1 to up to n. Now, what is this quantity? If you look carefully at this particular quantity, this is going to be nj number of terms for which this zji will be equal to 1. For the rest of the small n minus nj terms, this zji is equal to 0. So, corresponding to those, what we are doing is looking at the vector xi item and then looking at its deviation from its mean. So, this basically is giving us the within group sum of squares for cluster J, sum of squares for cluster J. And then we are looking at, when we are looking at trace of SW, we are looking at sum of that, basically average 1 upon n for each of these observations. So, this trace of SW is this quantity, and for different say prospective clusters or competing clusters corresponding to different partitions of the data, what one is looking at is to look at which of those partitions, which of those possible partitions is giving us the minimum value of trace of this SW. and that is what is the desirable quantity, because minimization of this particular sum here, minimization of this summation j equal to 1 to up to g of S g, where S g terms are within group sum of squares for that cluster G, is basically trying to look at what is the minimum quantity of that, because we are looking at the minimum quantity of these terms in each of these clusters. And what are these? It is basically trying to ensure that cluster number J is as compact as possible. So, if that particular jth cluster is as compact as possible, we will be having a minimum possible value of that S j corresponding to the jth cluster, and we look at over all possible such clusters, and that thus becomes a criterion. So, from the discussions that we are looking at this minimization of this trace of S w matrix is equivalent to the following, is equivalent to minimizing the total within cluster sum of squares about the G clusters. So, that is what is the interpretation of this trace of S w. So, it is valid that we can take this trace of S w as one criterion for choosing among possible partitions, among possible clusters in the data, because if we are looking at minimizing this particular quantity, we are looking at minimizing this quantity, and hence for every cluster J we are looking at minimizing this quantity, which is the within group sum of squares for the jth cluster, because it is looking at the deviation from that particular cluster mean, right. There are other criteria, I will say that other criteria, the following are other type of criterion, which are, say, looking at minimum of the following, that it is determinant of S w by determinant of sigma hat. This is actually minimum over all possible such partitions S b plus S w. So, it is looking at this particular ratio, which is the ratio of the determinant of the within cluster sum of square and cross product matrix S w, that divided by the total, which is sigma hat. Some other criterion are to look at maximum of trace of S w inverse times S b, or to look at minimum of the trace of sigma hat inverse times S w. So, there are other type of criterion also for looking at what is the best that one can actually look at while comparing various possible partitions of the data, various possible clusters that are coming. Say, for example, if one is considering a hierarchical clustering method. So, based on the threshold distance, one can have different types of partitions of the data, and then a criteria based on which one can actually look at the optimum partition of the data is to look at which partition is basically looking at the minimum or the maximum, whichever be the optimum criterion is corresponding to that particular setup. Now, let me look at some actual real life examples in order to look at the clustering analysis what we have learned so far. So, we look at some practical applications, practical data analysis concerning this cluster analysis technique. We will look at the standard technique. So, I will discuss about two applications. The first application is looking at the profitability characteristics of public sector banks in India. Now, the objective in doing that is we are looking at clustering of public sector banks, not only public sector banks actually, we are looking at, we will also look at other private sector banks and all banks pulled together. So, what sort of clustering does one can actually have when one is looking at all public sector banks operating in India based on their financial characteristics. Now, when we say that we are looking at financial characteristics of financial companies, it is not that we look at just one variable, it is usually a very high dimensional multivariate characteristic vector That is what is usually looked at, and thus we have the following case, that we have say k number of financial institutions, which in this case are public sector banks operating in India, and each of them has got a characteristic vector. The characteristic vector is based on say financial characteristics. Now there are various types of financial characteristics that one can define. In this analysis we have used the following profitability ratios. Some of them are derived from the balance sheet of the respective banks themselves. So we have these listed variables as the profitability ratios, like return on equity, return on asset, cost of deposit, cost of borrowing, return on advances, return on investment, operating profit to total assets, interest income to total income, other non-interest income to total income ratio, commission etc. to total income, net interest income to total assets ratio, and various other important financial indicators. So it is corresponding to each of the financial institutions. We will be having such a multidimensional data, where the dimensions of the data are these profitability ratios, right. So suppose we consider 25 such financial ratios, then each of the financial institutions, those are the items or the cases here, they are having a 25 dimensional data, and that is what is the problem, and we are looking at that multidimensional data and looking at what sort of clustering does actually emerge from such a data. Now we have learnt in the theory part what a hierarchical cluster analysis is. Remember, there are two approaches of constructing a hierarchical cluster analysis. One was the agglomerative algorithm, agglomerative hierarchical clustering analysis. The other one was a divisive clustering algorithm. We had discussed about different measures by which one can actually look at distances between various clusters, which is an important consideration when we look at construction of such hierarchical clustering. Now that theory is implemented in the following figure. We construct a hierarchical cluster analysis or a dendrogram tree from this Indian commercial banks. What we have here is a similar type of picture. That is what we were discussing in the theory part. So if we look at on the y axis, we have as before the linkage distance or the merger or the fusion levels. If we look at a very high distance, then all the banks appear to be belonging to one single cluster, and if we make the resolution level so fine that the distance is very small, then we will have all the cases to be members of singleton unit clusters. Now what we have here at the end is that we can see that, say for example, this is a branch here of the dendrogram tree, which actually have these following banks, which is the Bank of Rajasthan, United Commercial Bank, United Bank of India and Indian Bank. Based on the data, that is what we had for mid 2000s, actually 2005 or around 2006, the data was from that particular period. We see that clearly there is a cluster formation of these four banks, which is indicated from the branch. That is what we have from this. If we cut off the tree, the dendrogram tree at this particular level, we will see that mainly there are two branches. This is one branch under which there are four banks, and all other banks are in one single branch. If we get our resolution level down to this particular level, we will now find that there are 1, 2, 3 and 4 such branches of the tree, and hence 4 clusters in the data at that particular level. As we go down in the resolution, we make our resolution level finer and finer. We will have more and more clusters emerging. So if you consider the branch cutoff at this particular linkage distance, you will find that all these cases which are listed here and inside this particular figure, they are belonging to this particular branch. So those are sub branches of this particular main branch, and hence all the cases below this particular branch are belonging to one single cluster. The banks are indicated, which are these are basically new private sector banks, as you can see: ICICI Bank, HDFC Bank, IndusInd Bank and Development Credit Bank, and all those banks, Centurion Bank, are also present in this particular cluster. Now the big cluster here is the other banks which we have here. Now one can also slice it along this particular level and then look at various clusters that are formed. I have just as an indicative indication of these clusters that are formed, I have put these figure, so that these banks belong to one single cluster, these banks belong to one cluster, these belong to one cluster which are coming under this particular branch of the tree. Then these banks come under this branch here, these branches, banks come under this branch here, and so on. So you will find that the clustering that we have obtained at the end of the day, the hierarchical clustering, they naturally have a hierarchy in the formation of the clusters, and very interesting clusters do actually emerge. If you look at the last cluster that we have under this particular branch here, so this branch of the dendrogram tree branches out to include all these banks here. What are these? These are State Bank of India, SBI, and all its associates. So it is basically the cluster of all those State Bank of India and associates group, which of course have a similar structure of their business, and hence they belong to one single cluster out here. So this is how one actually gets to a hierarchical cluster analysis. Now a point that I had made when we were looking at the theoretical discussions of this particular subject, that such a hierarchical cluster analysis technique is not advisable if we have a large data set. If we have, that is, if we have more and more cases, the x-axis will become so crowded that it would be difficult for us to have such nice clusters as are formed in this particular data, and hence in such a situation one usually does not use a hierarchical clustering. If the data size is too large, one looks at a k-means clustering, which is a non-hierarchical clustering technique. Now if we apply a non-hierarchical clustering to the same data, we get such clusters. This is the output of a k-means clustering algorithm for the same data. We have in cluster 1 these banks, in cluster 2 State Bank of India and mostly its associates. You may note that this Punjab National Bank later on merged with State Bank of India associates. Cluster number 3 consisting of all these banks here. So each of these banks were initially from the data set were characterized by that high dimensional multivariate data, and based on the algorithm they have either been classified using say statistical non-hierarchical clustering method like the k-means clustering, or the hierarchical clustering method leading us to the previous figure of that dendrogram tree, right. You see a cluster 4 of these banks here, then we have a cluster 5 of these banks, cluster 6 for these banks. These are the clusters emerging not only from public sector banks, all commercial banks in India, including those what are those called, private sector, public sector and corporate banks. Then cluster number 7 are mostly good performing private sector banks, ICICI, HDFC, Times Bank, many of these banks later on merged. Then cluster 8 is the cluster of these banks. Now in the theoretical lectures we have also looked at the principal component analysis. Now principal component analysis is a very powerful technique for data dimension reduction. Not only data dimension reduction, it also looks at multi-dimensional projection of multi-dimensional data. And if we look at the data structure, that is what we have, it is basically multi-dimensional characteristic data, and then from a principal component projection of the same multi-dimensional data one can also look at some rough clustering in the data. So if we have the principal component projection applied to the same data, we have this 3-dimensional figure. The dimensions are the first 3 principal components. This is the first principal component axis, the second principal component axis and the third principal component axis. So each of these cases, each of these multi-dimensional data are now represented by the first 3 dimensions in the principal component, and then looking at that 3-dimensional figure one can once again come up with different clusters emerging. Now these are subjective clusters, of course. One can also have idea about outliers in the data, as was discussed in the theoretical lectures of principal component analysis. If you see that there is a bank which is in the Indian bank, this is Bank of Rajasthan, and these banks are clearly outlier banks which does not actually are included in the main data cluster in this principal component projection of the data. So these are some subjective clusters that are taken out from this principal component projection. Once again we see that there are some meaningful clusters, not as well defined clusters as the type of output that one gets from a cluster analysis technique like the ones that I have discussed just now. So this is a 3-dimensional principal component analysis projection and the corresponding clustering. Now, this is an interesting aspect of looking at this multidimensional data, something which is called a chain of phase. Chain of phase is a way to look at visualization of a multidimensional data vector, and it is a powerful technique actually, because if we look at dimensions 2, 3, one can visualize how the data is looking like, but if we have dimensions more than 3, then the data cannot actually be visualized. So, however, there are various techniques for visualizing those multidimensional data, and to me chain of phase is one of those methods which give us a nice pictorial representation of a multidimensional data. So, with the same multidimensional data used for the cluster analysis in this example, we obtain the chain of phases of all those banks. Now, to a layman, if you look at a phase here, the chain of phase actually represents multidimensional data through phases. Now, why phases? Because phases, phase representation or phase characteristics is one that one can easily actually decipher, and then looking at just the phase of that multidimensional data, what one can see is that corresponding to the health of that particular multidimensional data, if one is at all concerned about that. Now, in our example, we have the financial characteristics of financial institutions, mainly the Indian commercial banks. Now, if a bank looks smiling, like for example ICICI Bank, you will actually understand that that particular bank's entire multidimensional characteristics have been now represented by this particular figure, and if the face is smiling, you will associate the interpretation that the bank is performing well. So, you see that the ICICI Bank, the HDFC Bank, the Global Trust Bank, IndusInd Bank, J&K Bank, and some of the other banks have a smiley face. Some of the banks on the other hand does not look at all smiling, like for example the Indian Bank. So, the financial characteristics of this particular financial institution, the Indian Bank, is not at all good actually, and thus the facial representation of the multidimensional data gives a sad looking face of that particular financial institution. One can also look at multidimensional trends in the data through such chain of faces by looking at multidimensional data over a period of time and look at how the faces are evolving over time, and thus leading us to detect some sort of a multidimensional trend in the data. This is not exactly cluster analysis, but this is a multidimensional visualization or visualization of multidimensional data. Now, there are other ways of looking at clustering. What we have discussed in the theoretical lectures were statistical cluster analysis techniques. Now, apart from the standard classical statistical cluster analysis techniques, the clustering can also be obtained under different philosophies. Like for example, if we look at artificial intelligence approach, then self-organizing map is another method which actually leads us to looking at clusters in the data. They have several advantages actually over classical statistical cluster analysis techniques in various senses, that they not only give clusters in the data, they also look at how compact the clusters are. So, just by looking at the figure itself, the self-organizing map, what we have tried to produce here, these type of maps actually not only lead us to understanding clusters in the multidimensional data, but also lets us understand the compactness of each of those clusters, detection of multidimensional outliers, and how well the clusters are separated from one another. So, the same multidimensional data is used in order to get to this self-organizing profitability map of the data, now which is represented in terms of this beehive actually. So, this hexagonal blocks here one after the other, which is this two-dimensional representation. Now, we have well defined clusters as what we have. The banks in this region here have high profit, high business per employee, and they are basically the new private sector league of banks. Now, we have a nice cluster which is emerging out here, which are the high commission income to the total income banks, and all the banks here in this particular region are State Bank of India and its associates. So, they form a very compact cluster among themselves. Now, what is so common and what is anyway high commission? Commission is basically these State Bank of India and its associates, they perform all the government businesses, and the government, say for example, they take in income tax challans and etc. So, these are government businesses that these group of banks actually perform, and then they get commissions from the government of India, and that is basically a characterization of this particular sector here. We have a cluster being formed here. These are the banks which have high non-performing assets and cost of deposit. So, they are basically banks which do not perform that particular well. There are two clusters here, cluster number 4 and cluster number 3 and cluster number 2 here, which are formed from the self-organizing map here. Now, the way that clusters are detected from such a self-organizing map is that one looks at say patches of shades of white, leading us to believe that there say these, if two units here are separated by units which have a lower shades on a gray scale, that indicates that those two units are say some sort of closely associated and hence can be put in one single cluster. And thus patches of light shades in such a in such a SOM plane leads us to having an interpretation of the data that such areas actually are associated with formation of clusters in the data. On the other hand, if we find cases which are in the dark patches, we will understand that those are outliers. Now, this type of figure also is sometimes visualized using a 3-dimensional so called hill valley surface plot representation of this self-organizing map, wherein actually we look at a 3-dimensional visualization of this, where the dimension of say this color say either light shade or a dark shade of gray is now having a third dimension here, and thus here the valleys are places where the clusters are formed, and the peaks here are the points where outlying observations are present in the data, right. So, corresponding to the previous figure, when we had 1 here, 1, 2, 3 and 4, the same figure is represented in terms of that 3-dimensional hill valley plot. So, whatever cases were there in that one sector, which was State Bank of India and its associates, they are in this particular valley, in this hill valley plot here. Now, people in the valley, they we can say that they are like-minded people which reside in a particular valley, and the like-minded cases are basically put in this particular valley and which form a closed cluster, clearly separated from the other clusters, because the height of the hill lying in between cluster number 1 and the remaining clusters is quite well demarcated, and hence this is a very close compact cluster, and so is cluster number 2. However, the demarcation between cluster number 2 and cluster number 3 is not that well defined as that is for 1 and the rest of the clusters, although there is some height in between the two clusters 2 and 3. As regards to cluster number 3 and 4, we have the two or rather the characteristics of the two clusters are almost the similar. However, they are quite different as this particular dark patch here is indicating. Well, where is this particular location here? This particular location here is on a higher plane, which is located in this particular drop down there. If we look at this in this particular other side of the hill valley plot, we will have the other banks which were represented here, high profit and high business per employee, basically the more efficient private sector banks. So, clustering can also be obtained from such an approach of self-organizing map, which is an approach of an artificial intelligence technique. Now, the same data when we had the SOM representation and the hill valley representation or the visualization of the self-organizing map, this is another way to look at that particular clustering, which is called the component plane visualization, which actually looks at each of the constituent variables. Now, these were, remember, the variables which actually were used in that multidimensional data. So, we have this 15 plus 4, 19 such variables which had led to all the previous visualizations in the data. Now, looking at this also, one gets to nice interpretation of the clusters that have been formed in the data. For example, if you look at this particular region, that was the region corresponding to the high, let me just go back to that particular figure. This was the region where we had high profit and high business per employee, And if you look at the component plane visualizations, you have this business per employee, profit per employee. So, this on a gray scale, this is on a higher scale, and that is clearly a demarcating factor as far as the cluster that is formed of those banks. Now, if you look at another variable, say this is net non-performing asset. So, if these institutions were good from the point of view of business per employee, profit per employee on a high scale, they are also good from the point of view of this non-performing asset, keeping it down to a very low level, right. We will also look at another example, which is we are looking at socio-economic development of world economies. Now, objective in such an application is to cluster world economies according to the level of their economic or socio-economic development. So, in this example, we are trying to look at clusters of economies according to their levels of economic or socio-economic development. So, what is the data? The data structure is like that we have world economies, that is countries basically. So, each country, now in the previous example we were looking at financial status of financial institutions. So, there were a different set of variables on which the financial health of a financial institution is determined. When we are looking at countries, there is a different set of variables naturally, but the data still is multidimensional. So, we look at the following aspects of economic development and economic fundamental indicators. So, for example, for each of the countries in this particular study, we look at income level, which is given through the gross national product per capita at purchasing power parity rate, growth of the economy characterized by the gross domestic product GDP growth rate, the level of investment of a particular country measured by gross domestic investment as percentage of the GDP, then inflation measured through GDP deflator, then structure of output, agriculture and industry value added percentage of GDP, both as percentage of GDP. Then as a measure of openness of the economy, we look at export of goods and services, which is taken as a percentage of GDP once again. Then role of government, the general government consumption percentage of GDP. Then the later indicators are private sector financing, domestic credit provided by the banking sector measured as a percentage of GDP, net borrowing lending on account of merchandise trade, that is what is measured through the resource balance. Then strength of the foreign exchange reserve, that is the number of months of import cover of that particular country, and the ratio of gross international reserves to imports, efficiency of the financial market measured through interest spread of that country. In addition to these previous indicators, which basically are economic fundamental indicators, we also consider some social welfare indicators, because the health of a particular country is also looked upon when one is also concerned about the social welfare level of that particular country. Now, these are standard variables which are used in order to measure social welfares of various countries: illiteracy rate, adult female, life expectancy at birth, and various other labor force, female fertility rate, urban population, corruption perception index, and so on. So, the majority of the data have been collected from world development indicators. I forgot to tell you what is the source of the data for the previous application. The source of the data was Reserve Bank of India. The data source for this is the world development indicators of say indicators publication of the World Bank. So, the data corresponding to 2001 have been chosen, and the number of countries, that is the cases, is 125. So, what is the dimension of the data? That is what we have. If we have 25 indicators of economic development and socio-economic development and 125 such cases, we have in all 125 by the number of dimensions, say 25. That is the dimension of the data for this particular application. Now, once again we are trying to find clusters of economies in the data, which countries are similar in nature and so on. So, what we are first looking at an agglomerative hierarchical clustering analysis using SAS. So, in this example I also give you this particular part of the SAS code, which was not given in the previous application. So, this is basically the SAS code. This is how the data actually looks like. This is for the indicators which are actually for the social welfare indicators. So, these are the countries. ARG for example is Argentina, Australia, Austria, Bangladesh, Belgium, and all the data records, 125 records are there in alphabetical order. So, we use a hierarchical clustering method and obtain this hierarchical clustering dendrogram tree for the world economic development. Now, as you can see that there are various types of clusters that emerge in the data at various levels of resolution. So, broadly speaking, there are two types of clusters which comes under these two branches. So, all the countries below this particular main branch are coming in one cluster, and all the countries in this particular block here coming under this particular branch comes in one cluster. Now, that is a very gross representation, gross clustering of the data. We should actually make the level of resolution finer and then get to various types of groups of countries. Now, if one looks at carefully at some of these groups here, say this particular cluster here is a cluster of mostly developed countries. As you see, the countries here are Australia, New Zealand, Germany, Denmark, all these are abbreviated. So, GER corresponds to Germany, DEN we have Denmark, this is Sweden, this is Netherlands, this is UK, Canada, France, Norway, the United States, the Czech Republic, Spain. So, these are basically that cluster of countries which have nicely emerged when we have applied this hierarchical cluster analysis to this particular data. Right. Now, there are two countries which have a very close nature of association, which is Hong Kong and Singapore. Now, these of course are two countries which depend very heavily on export and import, and hence they have a very close nature of association. Now, there is another cluster of countries which is very close, which is Austria, Switzerland, this is Greece, Croatia, Portugal, Finland, Hungary and so on, which have a very good level of social welfare. It is interesting to find out where actually India is sitting. So, as you can see that IND is India, and we are sitting right next to Pakistan. We have PAK Pakistan here. So, this is basically the cluster here. BANG is the abbreviated form of Bangladesh. So, you see that from this particular branch here, there are two sub branches, one branch containing Bangladesh and India, and the other branch contains Pakistan. So, at this particular level of resolution, we have the socio-economic development level of India, Pakistan and Bangladesh almost in the same level. There are other groups, other interesting groups of countries that one gets. There is a group of country which is corresponding to say very underdeveloped African nations actually, that also is somewhere here. I am unable to see from this particular figure. One can find out that quite easily. This is Zimbabwe, Kenya, Namibia, Ghana and so on. They also belong, Botswana, that is the group of that African clusters, Botswana and all those, they belong to this particular close cluster out here, right. Now, if we look at the socio-economic development data, now the previous one was just economic development. Now, this has changed over the years. This is the data corresponding to 2001. This picture has changed. So, this is considering only the economic variables, economic fundamental variables in the multidimensional data, and in the next figure what we are going to see is the overall socio-economic development feature of this. Now, we see even more clearer clusters emerge actually in the data. There are three major clusters. This is one cluster, this is the second cluster, and this is the third cluster which emerges from this particular data. If you go coarser into this level of resolution, you will find that there are mainly two clusters. Now, what is this cluster? This is Australia, Germany, France, Netherlands, Hong Kong, Italy, Sweden, United Kingdom, Finland, Australia, Austria, Canada and so on. So, they are basically the League of Developed Nations. United States is sitting here, and so will be the United Kingdom, and Japan, Norway and all those countries are present there. And apart from this, there is also a close association of type of countries. Now, where is India? India is now belonging here. So, it is basically in the group of developing countries along with this Armenia, Zimbabwe and Cameroon, Nepal, Ghana, Pakistan, etc. So, this is the group of that socio-economic clustering that India belongs to, that is coming from the output of this hierarchical clustering method. There is also a close group of countries which were erstwhile Soviet Union countries, and they broke up after the Soviet Union actually broke into pieces. You will find that too in this particular figure, Armenia and those type of countries. So, they are also located somewhere here. We see a group of countries here which are basically European countries which are not as developed as this United States, United Kingdom, Spain, New Zealand, Portugal, Greece and so on, Czech Republic, Hungary, Argentina also belonging to this particular cluster. So, nice type of clusters actually does emerge from real life data. Now, as I was talking that statistical cluster analysis is not the only method to look at clustering, or rather to look at the type of cluster analysis, hierarchical or non-hierarchical clustering that emerges from a data. One can also look at self-organizing feature map, which comes under the philosophy of artificial intelligence. So, for the same multidimensional data, the socioeconomic development data, one can obtain a SOM representation of the data, and then the clusters in the data can also be found out actually. So, what we look at in the SOM is that patches of lighter shades gives rise to formation of clusters in those regions, and patches of dark shades actually separate those clusters, and cases which are belonging to those regions are outliers, like this is an outlier, CNG is Congo, ANG is Angola. So, these are outliers in the world economic development, socio-economic development map, and we see a clear formation of a clear cluster out here because we have a lighter patch in grayscale, and the countries all belonging to that particular patch here form one single cluster. And so, there is a cluster formation out here which is written as cluster number 4. These are all actually low income African countries, underdeveloped countries actually. So, all those are belonging to this particular cluster. Now, what is this cluster? Cluster number 3 are developing countries, mainly Latin American countries, as you see here, El Salvador, Paraguay, Bolivia, then you will have Ecuador, Brazil and so on, and Saudi Arabia etc. are also present in that particular cluster. Argentina, Peru, Venezuela, they are on the boundary of that particular cluster. Now, there is a strong cluster formation out here on the right side of this particular map. What are those? Those were erstwhile Soviet Union countries which broke up. These are Azerbaijan, Moldova, I think MLD, Belarus, Georgia, Ukraine and those type of countries, Kazakhstan, Russia are also in the boundary of that. Now, we have a very deep cluster here, very close compact cluster out here. What are those? Those basically are the countries which are developed countries, Austria, France, Denmark, Finland, Norway. These are Scandinavian countries, 3 Scandinavian countries, Canada, Sweden, New Zealand, UK, Germany, US, Japan, Switzerland. Now, on the boundary of that is also sitting Austria, Belgium, Netherlands, right. And on the right hand side we have a block of countries which are forming cluster number 2, which are East European developing countries, right, like Latvia, Croatia, Slovenia and Estonia, Slovakia and all those, right. So, this is the self-organizing map cluster of the same multidimensional data. As we had seen in the previous example, this self-organizing map, the previous representation is on the 2-dimensional SOM plane. One can look at the 3-dimensional hill valley surface plot of the same map, same clustering tendencies, and wherein the clusters are indicated by the valleys. So, this is cluster number 1, which was present in the previous map in this location. This is the cluster of the developed countries. You see that basically is sitting in this particular valley, very well separated by a high hill around that particular valley. So, the type of socio-economic development pattern is quite different of these countries than the rest of the world economies. So, the cluster number 2, which was on the bottom right side here, is now represented in this particular corner here. This is the cluster 3 here, this is the cluster 4 here. The location of India is somewhere here, India, Yemen and with Egypt, Morocco and all those countries sitting here. Pakistan, Bangladesh of course are very nearby to the type of patterns that India is exhibiting. Now, here once again we have this interpretation that valleys of lighter shade separated by hills indicate clusters. The hilltops, as we had discussed, this is a hilltop, this is another small hilltop. They are basically cases which are exceptional, atypical observations which are associated with outliers in the data. This is the component plane visualization, what type of things that we were discussing in the previous example also of this clustering tendency. Now, as I said that the principal component also is capable of giving us rough clusters in the data. This is a two-dimensional principal component representation wherein we have the two axes as the first two principal components in this data, and then if we have the projection of the data in the principal component plane, then we can also make out this rough clusters in the data, which are, these are of course subjective clusters that we have here. Well, the clusters that we have formed here, they are also quite subjective, but they have quite well demarcated boundaries. So you have cluster number this and cluster number this being separated by dark patches, and similarly cluster this and this separated by these dark patches, indicating that members in cluster number 1 are quite different than the members in cluster number 3 or 2 or this particular point here. So we have this as the principal component projection of the same data, and we also have a nonlinear projection, the Shamann's projection of the same data, giving us also some rough clusters in the data. So as we have learned that there are various ways of looking at this clustering patterns in the data. So once we have multidimensional data, we can either look at various options that are available. We can apply standard statistical cluster analysis techniques and obtain hierarchical clustering, leading us to dendrogram type of trees, and then make out clusters from that dendrogram tree at a desired level of resolution in the data. We can look at a non-hierarchical way of looking at that particular data, and then forming non-hierarchical clusters using a k-means algorithm, and then have clusters in the data. We can adopt a different approach. We can look at principal component analysis. We can look at the type of projection that a principal component analysis is capable of, and then once the multidimensional data is projected onto a lower dimensional visualizable plane, say up to 3 dimensions, we can look at that 3-dimensional or 2-dimensional projection of the data and then make out rough clusters in the data, or we can actually go completely orthogonal to what the statistical techniques have to offer. We can look at artificial intelligence approach, we can look at a self-organizing map. Now, well, I had given in this particular say presentation of looking at this real life data, and we had discussed about the self-organizing map feature, self-organizing map clustering techniques, but we have not looked into the theory part of it. That is beyond this particular multivariate statistical analysis course. These type of techniques are usually covered in courses on data mining or artificial intelligence applications. However, they are capable of giving a nice clustering of multidimensional data. The task basically is same. We are looking at multidimensional data, and we are looking at possible clusters that are emerging from the data. So the approach may be different. On a artificial intelligence mode, we are looking at self-organizing map to be the technique, and the output of that also leads us to same clustering of the data. Now, thus cluster analysis actually is usually which is a form of exploratory data analysis, is considered to be a step before we go on to other type of statistical analysis. Say for example, if we are looking at say regression analysis, one would actually try to, from a huge data set, one would look at homogeneous patches in the data, homogeneous cases in the data, and then apply further statistical analysis. For example, if one is interested in building regression type of models, one will not actually take into that particular one single model various heterogeneous blocks or groups of data. One would like to first have an idea about the number, or rather patches in the data, heterogeneous homogeneous blocks in the data, and then for each of those homogeneous patches, the clusters in the data, one can look at regression models in those different homogeneous patches. So cluster analysis to me is very important applied multivariate statistical method, and that is what we tried to learn in theory and also in practice. So from next time, next lecture onwards, what we will try to look at is another important multivariate applied multivariate technique of discriminant analysis and classification. Thank you.